we're going to continue analyzing using this tool, ARIO, to assess acidity and to understand and see if we can make predictions of acid strength based on these qualitative tool. So now we're going to talk about the inductive effect. So let's analyze another series of acids. And remember that the more stable, what we said, when we're making predictions, the more stable this is, the more stable the conjugate base, the stronger the acid. So that's what I'm doing now. Let's draw now a series of acids. This time I'm going to use, say, this is acetic acid, and then I have chloroacetic acid, and I'm going to have now dichloroacetic acid, and finally I'm going to have trichloroacetic acid. So here you're replacing the hydrogens on this carbon here. Every time I am replacing a hydrogen, here replace one hydrogen by chlorine, here two, here three. Oh, I drew here hydrogens we're replacing. So here we go. What we're doing here is this is trichloroacetic. So that's that. So to predict which of these acids will be stronger, then we're using the ARIO tool. So first thing we're going to look at then is what is the structure of the conjugate bases. So here are my acids. Now I am going to remove each of the hydrogens that are acidic. This one, this, and that. And I'm going to do it right here and draw my negative charges. So I am then the base is coming and getting the proton. So I'm doing, let's say, drawing the proton transfer mechanism here. So base get the proton, and then these electrons are assigned to the atom A, and I get my conjugates. So what I'm doing now is removing that proton. In doing so, I am going to be forming the conjugate bases. So this is what I have, and now I'm going to draw all my electrons here. That's acetate. Now I have chloroacetate, dichloroacetate, and trichloroacetate. Okay, what I see here, applying ARIO now. We see that the negative charge is on an oxygen in all those structures. So same in all of those. So let's analyze the next effect. Next effect is resonance. So we know all these anions, we can do resonance this way because we know one of these lone pairs is going to be delocalized, is allylic to this double bond. But I can do the same with all of these. And so I will be drawing the same resonance structure. So resonance alone cannot explain, I cannot predict what is a stronger acid in the series, so same effect. So we're going to be looking at now inductive effect. And by induction, we're going to be looking at differences in electronegativity between atoms. Well, we look here in a molecule such as, say, chloroacetic acid. Now, we have a dipole. You have a bond here whenever you have, say, carbon, chlorine. And you will have, say, other substituents here. This bond is polarized. We know it is polarized because chlorine is more electronegative, and we draw a vector this way. So delta negative, delta positive. So this is happening in this structure. So we will have chlorine is pulling actually away electron density from the reaction center here. And here I have 2 chlorine atoms. And here I have 3. Pulling electron density away. And the more I pull electron density, that helps disperse those electrons. And the more dispersed they are, the more delocalized, more stable this is. And the more stable the anion, the stronger the acid. So any effect, again, that helps stabilize the anion makes stronger the acid. And here what we're doing is we are have an electron withdrawing atom that's actually helping disperse the negative charge. So using that, I am predicting then that of this series, the trichloroacetate is a more stable anion than the dichloro, having only 2 chlorine. So if I was going to rank, now I'm going to order those. Because we know this effect, this is my inductive effect, I am predicting this is stronger. And second stronger will be dichloroacetic acid, because this anion is also stable, and so on. So I am predicting then that the order of acidity is the following. So acetic acid, acetic acid, let's do it. It's not erasing very good. Let's redrawing it again. So acetic acid is this, will be less acidic than chloroacetic acid. And this is, so we're talking here acidity and ranking. And this is less acidic than dichloro. And here, and well, I don't have real much room here, but I say the stronger of all of the acids here is the trichloroacetic acid. I'm running out of room. So we're predicting then that this, because this is the more stable anion, it's conjugate acid, so trichloroacetic acid is the strongest in the series. So, and I'm going to put now back my hydrogens, and that is because I think you can see that better. But probably not. Probably not. That's not going to help. Redrawing my acids. Now I have acetic acid, chloroacetic acid, dichloroacetic acid, and trichloroacetic acid. And ranking acidity, because again of the inductive effect that makes the conjugate base here more stable, we're going to, in acidity order, this is the strongest, so I'm going to label that number 1. This is number 2, this is number 3, and this is number 4. So this is the strongest acid because it will have that more stable conjugate base. And then we'll continue in another video with the last effect orbitals.